Okay, class. Good afternoon. Happy Friday. Unfortunately, I'm not there today. I'm feeling under the weather, but I wanted to record this lesson so we didn't fall behind. So today, our shape of the day looks like this. First, your warm-up. I want you to go to Khan Academy. You have made an assignment on Teams with a class code. I've made an assignment on Teams, and within that Teams, there's a class code. And so when you go to Teams, you would go to Khan Academy, and you're going to sign up to Khan Academy, and there's that class code that is within the Teams assignment. You're going to use that to sign up for Khan Academy. Next, since I'm not there, I've recorded this lesson on scientific notation. I want you to watch this as a class or individually. And then finally, for additional resources, we have this Khan Academy link, which has a series of videos and practice material you can go through. So I expect you to press pause at this point and go to Teams and sign up for Khan Academy. Some of you have already done this, and if you have, then you can just hit submit the assignment. All right, so go do that. Okay, now that you're back, let's talk scientific notation. What is scientific notation? Well, writing numbers in scientific notation is a way to represent a very large or very small number. We use powers of 10 to write numbers in a more compact form. So really quickly, why do we do this? Well, we use a number 6.02 times 10 to the 23 in chemistry all the time. And you will use it too. And here is a nice compact form that we use in chemistry. If we did not use this compact form, we'd need to write it out like this. 6, and we have this number 23, which you'll see later how to write this out. But essentially, this will look like this. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. 23 digits after the 6. And you can see this is not a very convenient number to manipulate if you're adding, subtracting, multiplying, and dividing with. So instead we use the more compact form shown here. But we don't know how to get there yet, so let's take a journey on to figure out how to get there. So today is November the 18th. And so we have here some important powers that we use. We've recently done a lot of work with exponents, so hopefully we can see this 10 to the 3 and we think of repeated multiplication. So how many times we repeat the 10? I hope somebody said 3 times. So 10 times 10 times 10. And 10 times 10 times 10, well, 1, 2, 3 zeros. Well, that's 1,000. What about 10 to the 6? Well, let's see. Well, we notice that 6 above the 10. Well, that 3 above the 10 here, notice how many zeros there are. 10, so we have 10 to the 3, and we had 3 zeros. 3 zeros. And that means then we'll have 1, 2, 3, 4, 5, 6 zeros to make a million. 10 to the 9 would be 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. That is 9 zeros for 1 billion, etc. And then we go 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 zeros for 10 to the 12. A little differently when we're talking the 10 to the negative 1. If you might remember, 10 to the negative 1, if we want to make that a positive exponent, would be 1 over 10. And 1 over 10 as a decimal equals 0.1. Likewise, 10 to the negative 2 would be 10 to the negative 2. Oops, I put a negative again. Let me just get rid of that. 10 to the 2, so be 1 over 10 to the 2, which would be 1 over 100, which would equal 0.01. So hopefully we're seeing a pattern here. So 10 to the negative 3 then would be 0.001. And 10 to the negative 6 would be 0.000001. And we'll see soon what we're actually doing is we can actually move the decimal over, back and forth. So converting from a standard notation to scientific notation. Oh, sorry, I guess we'll go back here. We do want to see that. What we'll do is we'll go back through these numbers here now. So 10 to the 3, what I want you to notice is if we put a decimal here, and we have this 3 here, notice that we go, there's 1, 2, 3 decimal places. Here, notice that there's 1, 2, 3, 4, 5, 6 decimal places. And here, notice there's 1, 2, 3, 4, 5, 6, 7, 8, 9 decimal places. And finally, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 decimal places. And with that, that's something we're going to be using later when we're moving back and forth from scientific notation to standard notation. And here, 10 to the negative 1, notice that we have 1 decimal place to make that a 1. So essentially, to make this number a 1, I moved the decimal over 6 times. To make this number a 1, I moved the decimal over 9 times, this one over 12 times. Here, I go the other direction, but once to the right. Here, negative 2, we'll notice 1, 2. Negative 3, notice 1, 2, 3. 10 to the negative 6, notice 1, 2, 3, 4, 5, 6. All right, so now that we've done that, let's actually convert some to scientific notation. So with that, converting standard notation to scientific notation. The exponent in the factor of 10 indicates the number of places that the decimal was shifted in order to write the number in scientific notation. The decimal is shifted until there is only one non-zero digit left of the decimal. So let's look at these ones. So we have here 3.5 million, or 33,500,000. And we start here with the decimal over in its normal place. And when we want to move into scientific notation, we simply count how many decimal places we can move over to make there only one non-zero digit. So 1, 2, 3, 4, 5, 6. And so we end up with 3.5 times 10 to the 6. This number here, we go 1, 2, 3, which gives us 3.5 times 10 to the 3. Here we move here 1, 2, once, twice, which gives us 3.5 times 10 to the 2. So hopefully you're seeing a pattern here. Here, well, that number is already the decimal is already where we want it to be. So we go 3.5, and if we wanted to write times 10 to the something, can anybody guess what that would be? So essentially, 3.5, we want it to be times 1. And so if we want this 10 to be a 1, we can raise it to the 0. Now we get into numbers that are getting smaller, but we want this we want this one to look like this. So we can move this decimal over once. And then we get 3.5 times 10 to the negative 1. And let's look at the next one. We go 1, 2, 3. Excuse me, other direction. 1, 2, 3. I goofed. Whoops. 1, 2. We want the 3 to be in the 1 spot. Sorry about that. So we go 3.5 times 10 to the negative 2. And so on. So here we count from here 1, 2, 3, which gives us 3.5 times 10 to the negative 3. And finally, we look at this last one, 1, 2, 3, 4, 5, 6. 3.5 times 10 to the negative 6. So that's how we convert from, say, standard notation to scientific notation. But what about from scientific notation to standard notation? Well, let's have a look at that. First, we identify the exponent. We have 10 to the 6th. Next, let's write down 4.2. And let's shift that decimal over how many times? Well, 6 times. 1, 2, 3, 4, 5, 6. And so what we'll do is we'll add some zeros. 1, 2, 3, 4, 5. So we've shifted over the decimal 6 times, add 5 zeros, and we end up with 4,200,000. And so let's do the next one. Let's write down 4.2 again. And And let's move that decimal over 3 times. Once, twice, 3. There we go. 4.2. Move the decimal over once, twice. 420. And 4.2, well, times 10 to the 0. Well, we don't have to move the decimal over because times 10 to the 0 is just 1. So this is the same thing as 4.2 times 1, which is just 4.2. Now I'm going to go the other direction. So I'm going to put my numbers over here now. And we have -1, which tells me to move the decimal over to the left once instead. So we end up with 42. Excuse me. Yeah, sorry, 0.42. That's right. So we end up with 0.42. And now for the next one, 4.2. Let's write our 4.2 again. And let's move the decimal over twice. So we're going to the left once and twice, which gives us 0.042. Again, let's write 4.2 here again. Let's move that decimal over 3 times to the left. Once, twice, 3 times. And we end up with 0.0042. And lastly, 4.2. Let's move that decimal over. 1, 2, 3, 4, 5, 6. Put our decimal 0.0000042. 0. So 0.0000042. Let's see, how many zeros did I say? 1, 2, 3, 4, 5. So 0.0000042. So that's how we're going to convert back and forth from standard notation to scientific notation and scientific notation to standard notation. Next, what about adding and subtracting these numbers? Well, let's do that. First thing we want to think about are numbers with the same power. Let's try numbers with the same powers first. What do I mean by that? Well, let's take 5130 plus 2140. Let's convert that into scientific notation first. So that's going to be 5.13 times 10 to the 1, 2, 3 to the 3 plus 2.14 times 10 to the 1, 2, 3 times 10 to the 3. And so what we can do, what we're going to end up doing is we're going to add up these numbers together first. So we go 5.13 plus 2.14, remembering to line up those decimals. So we end up 3 plus 4, 7, 1 plus 1, 2, decimal comes down, 5 plus 2 is 7. So we end up with 727. And notice that these are the same, and so what we can do is we can just add that on to the end. So times 10 to the 3. And that's how you would add those two numbers in scientific notation. First, we add up the numbers here, 5.13 and 2.14, and then the exponents we just add on to the end. All right, so let's draw another example. 35,000 minus 11,000. We can look here and we can convert this into scientific notation. So we count out 1, 2, 3, 4. This one also is 1, 2, 3, 4. And so we end up with 3.5 times 10 to the 4 minus 1.1 times 10 to the 4. So again, let's just deal with these. So let's go 3.5 minus 1.1. So 5 minus 1 is 4. Carry the decimal down. 3 minus 1 is 2. Once again, notice if these are the same, so they both have the same powers, and so we can just take that same power and write it next to our number. So 2.4 times 10 to the 4. Last example here. And let's do one with different powers. So numbers with different powers. So say I gave you this one to do. 2.1 times 10 to the 2 plus 3.5 times 10 to the 3. Well, what we'd like to do, what we need to do is these need to be common. We need to have the same exponent here, the same powers. And so what we can do is one of two options. We can either move this decimal over once. So this one here, we could move over the decimal once, or we can move this decimal over the other way, left once. So let's do it. Let's do this one. Let's move this decimal over here, and if we move the decimal of the 3.5 to make 35, then we can rewrite this same expression as 2.1 times 10 to the 2 plus 35 times 10 to the 2. When I moved this decimal over to the right once, this went down by 1 digit. And if you want, you can also just take this and go 2.1 times 10 to the 2 will be, we move the decimal over once twice, which would be 210. This one would be 3 times, so it would be plus 3,500. So we could count out our decimals. If we want 1, 2 here, that'll give us our 2.1. Here, if we want 2 decimals, 1, 2, we'll get 35. So that's how when we move this decimal over left to the right once, we moved it from here to here. So when we count it out, 1, 2. So this is times, let's move that over, times 10 to the 2 plus 35 times 10 to the 2. Okay, so here we just do that same thing again. We take 2.1 plus 35.0 173, carry the decimal down. So our final answer will be, now that we have the same powers, we can just rewrite the power next to it. So times 10 to the 2. And lastly, before I send you off to do some practice, multiplying and dividing numbers with scientific notation. So let's write out a number. 3 times 10 to the 2 times 5 times 10 to the 2. Well, here we can do something similar. What we're going to do is we're going to multiply these numbers together, and we'll also multiply these numbers together. So we're going to multiply them together separately. So let's do that. So 3 times 5, and then 10 to the 2 times 10 to the 2. So what we end up with is 3 times 5 is 15, and that's going to be 10 to the 2 and 10 to the 2. Well, that's going to be times 10 to the 2 plus 2, just that exponent laws we talked about before. So 15 times 10 to the 4. You could also rewrite this. You could also rewrite this as 1.5 times 10 to the 5. Another example. 1.25 times 10 to the 3 times 1.4 times 10 to the 2. So what we'll do is we'll take these numbers here, multiply them together, and take these numbers here, the powers, and multiply them together. So same idea as before. So 1.25 times 1.4. 4 times 5 is 20. Carry the 2 over. 2 times 4 is 8 plus 1 more. Or sorry, 2 more is 10. And then we end up with 1. So 1 times 4 plus 1 is 5. We've done the 4. Now we do move to the 1, so we're going to move to the tens place. So let's add a 0. 1 times 5 is 5. 1 times 2 is 2. 1 times 1 is 1. So we end up with 0, 5, 7, 1. So 1750. Now we got to count out our decimals. 1, 2, 3. So 1, 2, 3. So 1.750. Now let's take care of those exponents. And so we have 10 to the 3 times 10 to the 2. Well, just using our exponent laws, we can rewrite that as 10 to the 3 plus 2, which will give us 10 to the 5. So that'll just be times 10 to the 5th power. So we have our division or multiplication examples. Let's do a division example. So we have now 25 times 10 to the 4 divided by 5 times 10 to the 2. This could also be written as 25 times 10 to the 4 divided by 5 times 10 to the 2. Same thing. So what we're going to do first is take care of these, or in other words those, and then we're going to take care of the powers, or in other words these ones. So let's do 25 divided by 5, and then 10 to the 4 divided by 10 to the 2. Recall, 25 divided by 5 is 5, and then we have 10 to the 4. Recall our exponent laws. So division means subtract the exponent, so 4 to the minus 2. 4 minus 2, and that gives us 5 times 10 to the 2. So this here is what I would like you to work on. This should match up with the notes or the practice. So let's check that out. Let's make sure it does. So yesterday we did some of the percentage. We will go do a review on Monday for that. So no worries. So here we go. So let's just double check. We had page 59, 2.31 to 12. Is that what we have here? 2.31 to 12. Perfect. So what I want you to do is just after the next page after the percentage is this one here. And do the odd. Just like before, let's do the odd numbers. And so just like we did before, we'll take 3.5 minus 1.1. 5 minus 1 is 4. 3 minus 1 is 2. Carry the decimal. We have 10 to the 6 and 10 to the 6. They are the same. And because they are the same, we can simply go add 10 to the 6. And for example, this one here, we have, and to be clear, I think subtraction and addition is a bit more challenging than your multiplication. So I'll do one example like this, 1.01 minus 1.3. So we have 1 minus 0 is, 1. 0 minus 3, well, we need to borrow. So we'll take borrow from the 5 to make that 4. Then we have 10 minus 3 is 7. 4 minus 1 is 3. Now, at this point, you might be thinking, does this work? Well, in fact, it doesn't. Because what we needed to do first was account for the fact that these exponents are not the same. So what does that look like? Well, if we want these decimals to be the same, then we've got to shift over either the 5.01 to make that 10 to the 2, Or we need to make this 1.3 times 10 to the 3. Why don't we make this one the 10 to the 2? So let's see what that looks like. 5.01 times 10 to the 3 would make it 1, 2, 3. And this one, 1.3 times 10 to the 2 would be 1, 2. And so what we need to do is move the decimal over twice, once, twice. So that would be 50.10. Sorry about that. So we want to make these numbers the same. So what I did was I expanded it out. So this number here, 5.01 times 10 to the 3 is 5,010. I want this to be to the 2, so I move it over 1, 2 times 10 to the 2. So now I can rewrite this as 50.10 times 10, I'll zoom in a little bit, times 10 to the 2. So now we can take 50 instead, 0.10 minus 1.3, and then we do the subtraction. 0 minus 0 is 0, 1 minus 3, well, we can't do that, so we need to do some borrowing. If you want to use your calculator, of course, go ahead, but just make sure you're aware how to do this. You can take it from the 0, but the 0 needs to borrow, so let's borrow from the 5, the 10. This becomes a 10, but this number here, the 1 is going to borrow 1 from the 10, so that's going to be a 9 instead, and this will be 11. 11 minus 3 is 8. 9 minus 1 is 8, and then 4 minus 0 is just 4, and we'll add our decimal there. And so what we're going to, now that we have the same 10 to the 2, 10 to the 2, we can just add times 10 to the 2. This one, then you've got some questions where you're going to convert them into scientific notation first, and then, so this one, convert to scientific notation first. Because you'll be doing that one, but same idea applies. So best of luck. You'll just do that one. So we're just going to do 1 through 11. So basically you're going to do 1, 3, 5, 7, 9, and 11. All right, best of luck. Remember, there's a video from Khan Academy which gives you another deep dive if you need that help. Let's write that down at the top of our notes. Let's get there faster. To the top. There we go. So November 18th, and that was page, I assume page 20, and that was also 1 to 11 odd. All right, best of luck today. Thank you. Have a great weekend, and we'll see you on Monday.